All right, guys, welcome to the last section of the chapter 14.5, using the Pythagorean theorem. I know we already talked about Pythagorean theorem, how it's a squared plus b squared equals c squared, but we can also use it in different ways. So what we are doing today, you'll tell whether a triangle is a right triangle or not. We kind of talked about that already, and you will also be finding the distance between 2 points. You can find the distance between 2 points by using Pythagorean theorem. It seems weird, but it's very, very possible. So where do you use distance formula in real life? Well, Google uses distance formula to calculate the distances between two locations, right? It's not always going to be a straight line. If it was a straight line, you could just count 1, 2, 3, 4, 5, 6, 6 miles, right? But what if it's diagonal? You can't. You can't go from this position to this position if it's a street. You have to go up and across, right? So Google Maps uses distance formula to calculate distance, right? You can't cut across. So instead, you have to move vertical and horizontal. You can't just diagonally cut across, right? Let's see. No, I was thinking maybe that's walnut. It's not. I don't think so. So first, what is the distance between 4, 5 and 8, 2? So notice right here, we have 4, 5 and we have 8, 2. Now, if we want to draw a line across connecting the two, we can. It's perfectly fine, right? But that's not going to give us a perfect distance, right? Because this is diagonal. And I don't know exactly how much diagonal. Like, I know that this right here is a distance of 1. I know this is a distance of 1. I don't know what that is. Remember we talked about before, we said it's about 1.5, about 1.4, but it's not exact. We want the exact distance, right? And notice this doesn't cut through exactly these points right there, so we can't use it. But instead, what we can do is pretend we're Google Maps, and we are going to make a triangle. So notice, I'm going to move down this exact amount, and I'm going to move down this exact amount. It's sort of like finding the slope. Now, what is this distance right here? This is 3. What is this distance across? This distance is 4. So we can do a squared plus b squared and find our c squared. This is a value we want to find. So we can do 3 squared plus 4 squared equals c squared. And that's 9 plus 16 equals c squared. So 25 equals c squared. So if we take the square root to both sides, we get 5 equaling c. So the distance is 5. And I'm going to put units. The distance is 5 units using Pythagorean theorem. Before, you could not count. You can't go 1, 2, 3, 4, 5. Yep, 5. You can't do that. You have to use Pythagorean theorem in order to find distance. Hopefully that kind of made sense, but this wasn't really a formula. Distance formula is a specific formula. So now I'm going to show you guys what the formula actually is. You're going to think it's a little bit confusing, but I promise you guys it's not. It's just Pythagorean theorem in a different form. So what is distance formula? Well, distance formula is the distance between any 2 points given by this formula. So the 2 points are x1 comma y1 and x2 comma y2. And I want you to just look at the formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. And now I'm going to talk about where that comes from. All right? So the reason I'm going to talk about where it comes from, because it seems really random, a giant square root sign, but think about it. Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to write it different. I'm going to write c squared equals a squared plus b squared. That's the exact same, right? A squared plus b squared is c squared. But my goal is to get c, just that hypotenuse, right? Which is distance of d. So notice these two are the same. So I'm going to take the square root of both sides. So that means c equals, if I take the square root of both sides, I get a squared plus b squared. Well, remember your a is just going to be this part right here. And that is the difference between these 2 points. but it's horizontal. So that's x values. So that's going to be the difference between your x2 and x1. So that's why you're subtracting x2 minus x1, right? And then you're right here, that's going to be your b. That's the y values. So we are subtracting this value minus this value, y2 minus y1. So this a, in essence, equals x2 minus x1, and your b equals y2 minus y1. So that's where distance formula comes from. You're subtracting the two values to get your x right here and your y right here. Let's go ahead and do an example, and maybe that will kind of clear things up a little bit. So find the distance between these 2 points. So what we're going to do, we're going to find the distance between the x values and the distance between the y values. So if we find the distance between the x values, that means we need to subtract, right? So if we are subtracting, then that means we need to subtract x2 minus x1. So that's 2 minus a negative 6. Don't get tripped up on that negative. 2 minus negative 6 equals 8. We also need to find our difference in y values. So I'm going to do that in red. So 2 minus negative 4 equals 6, right? Now the formula goes distance equals square root of x2 minus x1 squared plus y2 minus y1. Oops, y2 minus y1 squared. So therefore, we found x2 minus x1 right here. So we're just going to plug in 8 squared plus y2 minus y1 is 6 squared. And we're going to take the square root of that and get our answer. So that's square root of 64 plus 36, which is square root of 100, which just equals 10. So the distance between these 2 points right here is exactly 10. Hopefully that made sense. I subtracted the two x values, I squared it. I subtracted the two y values, I squared it. And then according to Pythagorean theorem, you add those together, the a squared plus b squared, and then you take the square root of it and you get your answer. So hopefully you see here, we get, oops, my bad, went to the wrong slide. You get 10. So let's do the second one. So here we got 10. For the first one, let me write it down. It'll be taking a while. 10. For the second one, we have y2 minus y1 squared, so that's going to be 6 minus 1 squared, which is 5 squared, which is 25. And then we have x2 minus x1 squared, which is minus 3, minus another one, which is a negative 4. Well, negative 4 times negative 4, remember, is positive 16. So we found our y2 minus y1 squared, and we found our x2 minus x1 squared. Oops, mistake. I blame that mistake on my mom because she just came in. So I mixed up my x's and my y's. So we have 6 minus 1 squared, which is 5 times 5, which is 25. So that's your 6 and your 1. And then your minus 3 and minus 2. So minus 3 minus 2, which is negative 5 squared, which is another 25. So we found our y2 minus y1 squared. We found our x2 minus x1 squared. So we add those together. So we get 25 plus 25, which is 50. And then we take the square root of 50. So if we take the square root of 50, that's going to be your answer. All right. So we have 10. We have square root of 50. Let's just erase this. And now we have our last example. It's fine to have square root of 50. You don't need to simplify. You don't need to turn it into a fraction or a decimal. Leave it as square root of 50. That's okay. Last one, I'm going to write the full distance formula and then do the step by step. So I'm going to write rad 50 right here, and then I'm just going to erase that. Okay, so distance equals square root of y2, or I'm going to do the x's first. Doesn't matter, but x2 minus x1 squared plus y2 minus y1 squared, right? The difference in the x values, difference in the y values. So distance equals, well, your x2 is going to be 4 minus 1 squared plus y2 is negative 5 because it's the second y value minus a negative 7. Oops. Minus a negative 7 squared. So distance equals 5 squared plus, well, negative 5 minus 7 is negative 5 plus 7, right? With negative 5 plus 7 is going to be a 2, so that's 2 squared, and then you have the square root. So distance here equals square root of 25 plus 4, so distance equals square root of 29. So these are your three answers: 10, rad 50, and rad 29. All right, let's go ahead and go to the next example. Tell whether triangle is a right triangle. Now, in order to tell if a triangle is a right triangle or not, what you can do is use Pythagorean theorem. So remember, the longest side is always going to be your hypotenuse, right? So pick your longest side and notice that the longest side right here is 41. Therefore, that's going to be your C, that's going to be your A, and your B. So 9 squared plus 40 squared has to equal 41 squared. 9 times 9 is 81. 40 times 40 is 1600. And then you can do 41 times 41. So let's use a calculator. That's fine. 41 times 41 is 1681. So I get 1681 equals 1681. Check. Done. Yes. For the second one, this is going to be my hypotenuse, so we're going to pick this as A and B. So that means 18 squared plus 12 squared equals 24 squared. So 18 times 18 is 324. 12 times 12 is 144. And we want to see if that matches up with 24 times 24. So that's 576. So if we add together 324 plus 144, we get 468. Oops. 468. 468. Does that equal 576? Nope. So this answer is no. It is not a right triangle. So let's go ahead and show you the steps for that. It's the exact same thing that I did. So it is a right triangle. The next step, it is not a right triangle. Right? And that's it, guys. So distance formula, go back to those old examples. Look at what I did. Subtract the y values, square it. Subtract the x values, square it. Add those two numbers together, square root that answer, and you are done. It's the same as Pythagorean theorem, just using points. All right, guys, that's the last lesson of the chapter. Good luck, and I hope you guys have a good rest of your day. I will see you guys later. Bye.